All right, so today we are going to be looking at periodic trends, and we are really just looking at things that you have already learned. The only new thing that we're going to be looking at today is Lewis dot diagrams, and they're super easy, so hopefully this is going to be an easy activity for you guys today. If you do not yet have your periodic table, you're going to need a periodic table and some map pencils, because we're going to be marking it up as we're going through the notes together and answering questions on the Edpuzzle. So we're going to start out with periods and groups on the periodic table. So in order to look at trends, you have to understand that the first trend is the elements are organized in order of increasing atomic number from left to right. Those left to right rows are called periods. So we have hydrogen in period 1, period 2 starts out with lithium, period 3, period 4, period 5, period 6, period 7. Remember your lanthanide series here is actually part of period 6, and your actinide series is actually part of period 7. So those are still in those same basic periods. Your groups are the columns of the periodic table, and they are organized by characteristic. So element characteristics, valence, all of that kind of good stuff. And you have a group 1, 2, 3, 4, 5, 6, all the way to 18. We are going to be primarily concerned with groups 1, 2, and groups 13 through 18 for the time being. So those are the groups. They are also sometimes referred to as families. So we're going to look at those in a little bit. One of the things you should have first learned about the periodic table and should have reinforced throughout your science career up to this point is that the basic organization is the elements are grouped into groups of metals, nonmetals, and metalloids. The metals are primarily on the left-hand side of the periodic table, with the exception of hydrogen right here. They typically have a shiny luster. They are malleable and ductile, which means they can be pounded into a sheet or pulled into a wire. They are mostly solids. They are very dense and good conductors. Nonmetals are the opposites of metals. So they are the blue elements over here, mostly on the right. And then hydrogen, of course, is a nonmetal. And so they are not shiny. They are dull. They are not malleable and ductile. They are brittle, which means that if they're in solid form, they tend to break when put under pressure and crack. And they are mostly gases. So there are some solids in there in the liquid. However, at room temperature, most of these nonmetals are going to be gases, and they are poor conductors. So again, opposite characteristics. And then metalloids are in the middle, and as to be expected, they've got some characteristics of both. So metalloids tend to be shiny like metals, but brittle like nonmetals. Instead of good conductors or poor conductors, they tend to be semiconductors. They have a medium density compared to metals and nonmetals, and they tend to be solids at room temperature. So that's the general information about metals, metalloids, and nonmetals. You're definitely going to want to write in that staircase here. Remember, it starts with boron, and everything touching the staircase is a metalloid with the exception of aluminum. Aluminum is going to be a metal. So that kind of helps you to distinguish those nonmetals on the right of the staircase, the metals on the left of the staircase, and the metalloids along the staircase. All right, so our major groups that you need to be familiar with are the alkali metals in group 1, the alkaline earth metals in group 2. These are metals that are our most reactive metals. Group 1 is going to be more reactive than group 2, typically. Then over here, your groups 13 through 17 are going to be identified primarily by whatever the element is on top and the name of the family. There are some other names for them occasionally, but we're just going to call them the boron family, carbon family, nitrogen family, and oxygen family until you get to group 17. These guys are the halogens. They're also very reactive, and we'll look at that in just a little bit. And non-reactive, the opposite of that, is going to be our noble gases in the white column here. They have a full valence, so it's all about how full is the valence. And that kind of impacts how reactive an element is. And these guys have a full valence, so they don't really tend to bond at all. And so you tend to find them just kind of on their own in nature most of the time. Other important groups of elements, your D blocks here are the transition metals. There's a special group of transition metals called the rare earth elements that consists of the lanthanide series as well as the other elements in group 3. Those are really important. We use them in a lot of technology, industry, and things like that. And then you've got your actinide series as well. These are things that we're not going to be quite as concerned with in this upcoming unit, but it's important to understand that these are all metals. And then these are going to be our non-transition metals, still metals here. So up here we've got some metals, metalloids, and non-metals all kind of in these same families here. So when we're looking at our families, the ones that we're mainly concerned with for this upcoming unit are groups 1, 2, and 13 through 18. Their group numbers actually tend to be quite convenient because here the group number 1, if it's in group number 1, it has 1 valence electron. In group number 2, it has 2 valence electrons. And now these are groups 13 through 18, but if you just remove the 1, you still have the valence electrons identified. So group 13 has 3 valence electrons, group 4 has 4, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8. So for a full valence. So that is something that's going to be important. So we've got these valence electrons according to their group. And remember that elements tend to be reactive and bond based on their valence. So my elements that have 7 valence electrons are going to be really reactive with my elements that have 1 valence electron because 7 plus 1 equals 8. So we're going to look at those trends in our upcoming unit. It's important to understand that valence determines bonding characteristics. It also determines other chemical properties. So everything in group 17, my halogens, they all have similar properties. They bond with similar atoms in the same way. And the same thing is true for element 2. All of my alkali earth metals are going to have similar properties and bond in similar ways with similar elements. The only new thing that we're looking at has to do with valence. And so that is our Lewis dot structure. So our Lewis dot structure is simply a dot with the chemical symbol. The dots are representing how many valence electrons there are. So this would be an example of hydrogen. It has 1 valence electron. Oxygen has 6 valence electrons. So this will be an example of oxygen. Instead of X, you would have O here to represent oxygen or any other element that had 6 valence electrons. And my noble gases will all look like this with 8 valence electrons. And a full valence there, and then those symbols will be substituted for the X. It is important when you're creating a Lewis dot structure that you understand it kind of fills up like our electron orbitals. So here you can see 4, you distribute the 4 electrons all the way around the symbol, and you don't start doubling them up until you get to 5. So this is where you double it. Wherever you start and wherever you start to double is up to you. You don't have to follow the same pattern here as long as you don't have them doubled up until you get to 5. You have 1 spare slot on each side. This is what the elements look like in groups 1, 2, and 13 through 18 with their Lewis dot diagram. So again, the same thing as what we saw before, but with the actual symbols. And so what you're going to be doing then is simply identifying the valence of each of our major groups and writing in this same X with the Lewis dot structure above your periodic table. So hopefully at this point you are all ready to go, and you've got a colored and marked up periodic table. We're going to be taking those up at some point this week. Hope that helps.